Well, hello, scrappers. Mike here. Welcome back to my channel, and welcome to episode 4. Yes, we're up to 4 episodes of dealing with this silver wire that I got as a donation from a viewer of my channel, Justin. And, back in episode 1, which I'll put a link to in the upper right, basically we unpacked it and took a good look at it and sort of brainstormed different ways to deal with it. In episode 2, which I'll put a link to in the upper right, I cut off a foot of that cable. There were actually a whole lot of different conductors in that cable. I didn't actually even count them. I don't remember how many there were. A whole lot of different conductors in that cable. They were all shielded twisted pairs, all insulated with Teflon. So I cut off a foot and I very laboriously stripped a foot of that cable, and it took me a long time, ruined my thumbnails, aggravated the arthritis in my fingers. It was annoying. Okay, and I decided that, well, no amount of silver was worth that much work. Episode 3, I took the stripped wire and I dissolved it in nitric acid and then cemented the silver out with copper, and we figured out that a little less than 4% of the wire was silver. So really, not that much silver there, and it's very difficult to get. At that point, I was about ready to just chuck the whole thing because the value added from the silver is not worth the effort to get it, in my humble opinion, okay? Uh, Less than 4% silver underneath all that Teflon insulation. Yeah, I would say your best bet, Justin, anybody else with this kind of wire, just take it to the scrapyard and take whatever they'll give you for it. Because I don't see any good way to get the silver out, economically, unless you're really a glutton for punishment, which apparently I am, because this is going to be video 4 on this. But at the end of video 3, another of my viewers, Tim Toolman4125, came through and he said, "Hey, I've got a granulator. I'll granulate it for you." And I thought, well, at least not having to strip the stuff makes life a little easier. I'm still not sure it's worth the effort of extracting the silver from it, but at least it'd make extracting the silver easier, not having to strip it. So I shipped the wire off to Tim Toolman, and we've emailed back and forth quite a bit in the couple weeks since then. And basically, Tim's had a lot of trouble with it. Those of you in the comments on the last couple of episodes of this who said that a granulator wasn't going to work, well, apparently you were right, because Tim's having a lot of trouble with it. He has sent me back some of it. I'm not sure just how much of the wire he processed. So I think he said he was going to do like 5 feet as a test. I'm not sure. He sent me back some wire here, or what's come out of his granulator anyway. It's not wire anymore. But he's having a lot of trouble separating the insulation from the wire. The wire is very fine. It was shielded twisted pairs. The shielding over the twisted pairs was very fine. It was woven from very fine wire. And the central conductors, well, they were stranded, and the strands were very fine. And I guess he's just having trouble separating the wire from the Teflon insulation. So, yeah. So here's what he sent back. I'll zoom in on that for you. Yeah, there's a lot of insulation still in there, for sure. Clearly, his granulator is having trouble separating the wire from the insulation. I can see shiny bits of silver all through it, but there's a whole lot of white Teflon insulation and some blue Teflon insulation. Let's see how much he sent back, though, okay? Let me get this up on the scale and see. One thing I don't know, though, so we're right about 1.5 kilograms, 1,496 grams. So as I recall from episode 2, when I weighed a foot of the wire after cutting it off, it weighs 214 grams. So 1,496 divided by 214 equals, well, that would be says 7 feet there. But yeah, I think he said he did 5 feet. So maybe, I don't know. I don't know. So anyway, like the equivalent of 7 feet of wire here in this bag. But of course, there's still a lot of insulation here. And for all I know, there might be more insulation there. I don't know. I don't know. Let's dump it out and take a look at it and see if we can brainstorm something. I'm spreading it all over the place. It's very light and fluffy. I'll zoom in again. So yeah. Okay, yeah, there's a lot of silver-plated wire there. I can see it, but there's a whole lot of Teflon insulation there too. Now it looks like the wire's been chopped really small, but the insulation's still in fairly big pieces. So what we got to do here is figure out a way, if I even want to continue messing with it. I don't know. Might be want to just cut my losses, but figure out a way to separate the insulation and the very, very fine wire there. Now, burning it. I know a lot of you are reaching for your keyboards to leave a comment. Just burn it. Just burn it. Well, no. This is Teflon insulation, okay? ETFE. Burning it, assuming you can get it hot enough to burn, because they put this stuff on frying pans, so it can take some heat. But assuming you can get it hot enough to burn, you're going to release hydrogen fluoride gas, which is about the most toxic stuff you can imagine. A couple of lungfuls of that, and you're dead. Maybe even one lungful of that, and you're dead. There is no coming back from breathing HF. So, yeah. And if you can't get it hot enough to burn, well, it's probably just going to melt and turn this into one big solid lump of metal plastic gunk. So I think burning it is just not viable in any way, sense, or form. So there won't be any burning of this stuff. I'm assuming, since this is dry, that Tim's granulator uses air methods. Correct me if I'm wrong, Tim. Possibly airflow to separate wire and insulation. But it looks to me like the wire is very fine compared to most of the pieces of insulation here. So I'm still thinking a gravity method might work for separating these. It would be great if Teflon floated, but it doesn't. It's heavier than water, so you can't just float the Teflon off. It's a very dense plastic. But still, I'm thinking a gravity separation method, a density separation method would still work, because the wire is going to be a couple times more dense even than the Teflon still. But the wire is very, very fine. So I'm thinking maybe this needs to be sifted or classified before attempting a gravity separation, and that might work. I'm an old-time prospector. I'm always thinking gravity separation for concentrating metals, and that works. It's worked for hundreds of years, thousands of years, and it's simple. But the old-time prospectors have a saying: separation without classification is impossible. So I'm thinking we need to classify this stuff by size, and I'm thinking a lot of this fine wire will go right through a small mesh, and a lot of this insulation is going to stay behind, and that would concentrate the wire something wonderful. And what we'd be left with is wire and bits of insulation of roughly the same size. And then once they're roughly the same size, the difference in density between them makes them easier to separate, whether by air, flowing water, whatever. So I'm thinking what I need to try to do some experimenting here. I mean, what the heck? We've come this far. You know, a little experimentation isn't going to hurt. It may not be economical to get the silver out of this, but you know what? Darn it, I don't want this wire to outsmart me. So we're gonna do a little experimentation. I'm gonna try sifting some of this and see if I can concentrate the metal and leave behind a lot of those bigger flakes of insulation. And then maybe we'll take the concentrate and try running it through a sluice, maybe a mini cleanup sluice or something, and see if that further concentrates the metal and washes the insulation out. So I think that's what I'm going to try. So I will get set up for that, and we will give it a shot. It may be a complete waste of time. It may not be a practical method of dealing with this, but we're going to give it a try since we're here. And Tim was kind enough to run this through his granulator. So, okay, let me get set up for that, and we will see what happens. Well, I've been doing some experimenting over here with different size sieves, and it looks to me like the 20 to the inch sieve does the best job of separating the wire from the insulation. Now, there's still some wire in here, a little bit, but I would say 90% of the wire goes through the sieve and 90% of the insulation stays behind. And what we got down here is looking like mostly silver wire, okay? So this is actually working. It's concentrating the wire. Let me empty out my sieve again. So like I said, I'm not getting all of the wire, but we're getting the vast bulk of it. A little bit more in here. And just shake, shake, shake your booty for a good long time here. And you start to see that the wire disappears and most of the insulation stays behind. Yeah. I'm thinking that about a 20 to the inch is best. I don't really see much advantage to going anything smaller because I'm getting a lot of wire caught in the 20 to the inch screen. So I could try a 30. Well, maybe for just S's and G's, I will try running some of this stuff through a 30 and see what happens. If it doesn't just plug it all up. It is a little time consuming, but I have larger screens that'll fit over a 5-gallon bucket, so I could do quite a bit more at a time. This is just R&D experimentation here, just to see if it works at all. But this is like my third sieve full, and look at all the silver wire I've got in here. So it's working. I mean, there's still some Teflon there, but like I said, I think I'm leaving 90% of the Teflon behind and getting 90% of the wire through just by eyeballing the way it looks here. That would be my best guess. I mean, this is pretty denuded in wire. There's still a little bit in there, but not much. And this is pretty denuded of insulation. There's still a bit in there, but not much. So let me find my 30 mesh screen, and I'll try running a little bit of this through it and see what happens there. Okay. I don't know. I don't have a lot of faith that this is going to do anything other than clog up the screen, but we'll see. Yeah, wire's coming through, but not much. See, on a screen, that's fine. The wire's long enough. It's got to line up just so it goes straight through the screens. And I suppose if I stood here and I shook this for 2 or 3 hours, I could probably get the bulk of the wire through, and it's coming through pretty clean. But really, I'm thinking 20 to the inch is probably the most practical screen size. I mean, it's working. That is very clean silver plated wire down there coming through. But I've only got maybe, after all this shaking, 10% of it through. So I'm thinking 20's a good compromise. Yeah, I think 20's a good compromise. Yeah, goes through a lot quicker with a 20. Yeah, we get more insulation, but you know what? Time is money too. And it's just not economical to spend a lot of time and or money on trying to get the silver out of this stuff. There just isn't enough there at about 4% to make it worthwhile. All right, so screening helps concentrating. Good to know. So I'm going to concentrate a little bit more, just so we got enough for a decent sized sample. And then I think we'll try a gravity separation, maybe in a mini cleanup sluice or something, and see if the water will separate the rest of the Teflon away from the metal. Possible it won't work, but it might. So let me get set up for that, and we'll give it a try. Well, I was all ready to set up my mini sluice, my mini cleanup sluice, and run this stuff through it and see if I can clean this wire up any better. And well, it's a day or two later, and I've had a bit of a rethink about this, and I've been emailing back and forth with Tim Toolman a lot. I told him that running this stuff through a 20 mesh sieve gets rid of most of the insulation, and running it through a 30 mesh sieve gets rid of pretty much all of it. And he says, well, I've got an automated flour sifter here, and I can put whatever size screen in it I want. I'll just try that. So he sent me a picture of some that he's run through it. I can't remember whether it was a 20 or 30 mesh screen, and I said, wow, that looks pretty clean. He says, I'm going to try an even finer screen. I said, well, do it if you feel like it, but that looks pretty clean to me. So anyway, and I'm having a bit of a rethink about how to process this stuff. I mean, I've already decided that this is a losing proposition, trying to get the silver out of this. There's no way you're going to do it without being in the hole, pretty much. Okay. I mean, even if you've got all the toys like Tim Toolman does, if you've got a granulator, you've got a flour sifter, okay, fine. That's great. You're going to have to do all that for wire anyway. But getting the silver out, I can't think of a way that's economical. Now, some people in the comments have suggested that I try 3/9 Doosan's way. So I had heard that he had a way of stripping silver. He calls it poor man's silver stripping solution or something like that. So I went and I watched his video, okay, the other day. And I'm like, I don't see how this is working. I mean, without the silver re-cementing out on the remaining copper. I don't know. He says he uses sulfuric acid to passivate the base metal. I don't know. It doesn't look like it ought to work to me. But I'm thinking we should at least try it. Okay, I've got this much material here. All right. We can do an experiment and see if it works. If it works, I mean, we could probably do it on this stuff without having to do any further treatment to it. The only reason I was trying to get rid of as much of the Teflon insulation as possible is I was thinking about possibly melting this stuff down and making electrodes or making anodes for use in an electrolytic cell. Well, I got to thinking about that. The propane equals money, electricity equals money, time equals money. That'll put you in the hole real quick trying to recover less than 4% silver out of this stuff. So I'm thinking, let's just nix that whole idea, okay? Nix that whole idea. On a hobby scale, if you want to do it for fun, you're willing to absorb the losses, that's one thing. But I'm always thinking about, large-scale recycling and refining. And I know, I got 20-odd pounds of this stuff. Justin has a lot of it. Other people have a lot of it. And if you're gonna recycle, reprocess, recover the silver on a large scale, it's got to be economical. Nobody can afford to lose money hand over fist to get a little silver. So we're gonna try 3/9 Doosan's method, and see if it actually works. If it does work, then, well, we don't need to separate the insulation quite so thoroughly because we're not melting this stuff. We don't have to worry about giving off HF fumes into the air. Um, so, yeah, so we'll try that. If that doesn't work, I've got another idea. Again, it's probably not economical. It's probably not worth the time, but we can try it. It won't cost me much, and we'll see if that works. But we'll try 3/9 Deucens method, and I'll put the mini sluice away again. Maybe. I got some other projects I can use it for while it's out. So, anyway, let's get some of this in the fume hood and get started. All right, let's see if we can emulate 3/9 Deucen here. I'm going to take 100 grams of this pretty cleaned up material here. And we will work with that. From my experiments in previous videos in this series, I know that from 100 grams I should get close to 4 grams of silver. Okay? So if this process works, that's roughly what we should get. 4 grams of silver. Because this material is right around 4% for my tests silver. The rest is copper. Come on. 100 grams. Okay. Close enough. All right, let's get this in the fume hood and get started. Okay. So I've been rewatching 3/9 Deucen's video, and these doesn't go into a lot of detail about the quantities he uses on anything. And it looked like he used a whole lot of sulfuric acid, but didn't give me a measurement on it. And then I saw him put some sort of nitrate salt in there. At first I was going to use potassium nitrate, which in an upcoming video I'll show you how to make. So a lot of my viewers can't buy it apparently. I'll show you how to make it in an upcoming video. It's pretty darn easy. And the chemicals you need to make it are pretty much available everywhere. But after carefully watching 3/9 Deucen's video again, I see that he did say he used sodium nitrate. Now, I kind of doubt that which nitrate salt I use is going to have any effect on this reaction. But if this doesn't work, I know everybody's going to jump in the comments and say, you used the wrong nitrate salt. So just in case those sodium ions are necessary somehow to make this work, we'll use a sodium nitrate instead of my homemade potassium nitrate. I'll put this away again, and we'll get going. But like I said, he's not really telling me how much of anything to use. He just puts a couple little spoonfuls of this stuff in, and it looks like he uses a whole lot of acid compared to the amount of water he uses. So, I don't know. We'll give it a try and see what happens. Okay, so let's give this a try according to his sketchy, incomplete recipe. So now, I'm going to be working with silver-plated wire here. In the video I watched, he was working with silver-plated contacts, which had nickel plating underneath the silver, which I can see how that nickel plating would be fairly inert. I'm going to put a little more water in there. He covered everything with water first, distilled water, and I actually have some distilled water today. Sometimes it's hard to find around here, but I actually have some today. Make sure this stuff's good and wet. It's kind of clumpy. Okay. Got some floating insulation in there, but I'm not too worried about that. Alright, so next we're going to go with concentrated sulfuric acid. Now, it looked like he used a whole lot of acid, like almost as much acid as the water he put in here. So, let me put in a fair amount of acid. This is going to get really hot by adding this much acid. Okay. So I would say that's a pretty close approximation to what he did. I don't know, this stuff's pretty clumpy though. his contacts, there was a lot of space between them, you know? All right. He didn't use any external heat, so I'm not going to turn the heat, I'm not going to turn the hot plate on. I'm just going to put in a spoonful. Well, he put in like less than half a spoonful first, and then he did it another less than half spoonful later. So let's see, about that much. And yes, we get an immediate reaction, which I was expecting. Oh, frothy. You just let that react. So watching the video, he just basically let it react until it was done. And I don't know if you can see, but the liquid is turning green, so that tells me we're actually getting some copper in solution, which is exactly what I was expecting to happen. What I don't understand is what is preventing the silver from cementing back out on the copper. I guess we'll find out. Let me put another. Let me put another small partial spoonful in. Oh yeah. This reaction makes nitric acid, also known as poor man's nitric. If you can't get or afford nitric acid, this is one way to get nitric acid in your solutions. So, okay, I'm not sure what's happening in there. I still see a lot of silvery looking wire. Well, you know what? Actually, that wire is looking kind of coppery. I wonder if this is actually working. The wire is not nearly as silvery as it was. It's kind of more of a coppery look to it now. I guess I'm zoomed in as far as I can go there, keeping the camera out of harm's way. Get a closer look at that. I don't know. Might actually be working. I'm going to put in one more small spoonful. He put in only two, but I think I still see some silver in there, so we'll do one more. Those fumes dissipate. Okay. Just let that sit until it looks like it's done reacting. And then I'll pull it out and we will filter the liquid off and test it and see if it has silver in it and get a look at what the wire looks like that's staying behind. All right, so 3/9 Deuces' next step was to cotton filter the liquid through a funnel. So I got a funnel here, I've stuffed some cotton in it, and we will cotton filter this stuff and see what we get. And we'll see what's left in the bottom here in a second. Well, that's interesting. Let me get this under light, and we'll take a close-up look at it. This is coming through pretty clear, so I'll just let that continue to drain. Let's have a look at the wire. Well, the wire has definitely lost its silvery sheen. Whether all the silver is gone or not, I can't tell. Maybe it's just tarnished. I don't know. It's interesting. We might try giving this a second treatment if it looks like there's not a lot of silver in there. Okay? But something definitely happened. Good, bad, or ugly, though. I'm not sure what. I guess we'll find out. So I'm gonna rinse this stuff in here a little bit and dump the rinse water into the funnel there to make sure we get as much of this solution out of here as we can. I need to refill my wash bottle down to the last dregs. All right, I might give this another rinse and then we'll just let this drain. All right, the filtration is essentially done. Let's mix up a little solution here to test for the presence of silver. So we got some tap water. Put some tap water in here, enough that you can see what's going on. And a little splash of muriatic acid in it. Just a little splash is all we need. That should be plenty. Stir it up good. Let's get some of this liquid. Uh-huh. Well, that's a problem. There's essentially no silver in there. Okay? Yeah, that liquid is still clear. If there was any significant amount of silver dissolved in that stuff, this liquid would be all cloudy. Okay, so I don't know what I did wrong. If you have a comment, a suggestion, hey, 39 Newson, if you see this video, tell me what I did wrong, okay? Did I just not let it sit long enough? Not use enough sulfuric acid, though I thought I used plenty? What did I do wrong? Because we got no silver here. The silver apparently is still in here. I guess it's just all tarnished now. Man, I was really hoping this was going to work, too, because this is a relatively cheap method, you know, if it worked. Maybe it was just because the stuff he was working with was nickel-plated. And the nickel the sulfuric acid passivated the nickel. I don't know, but it certainly didn't passivate the copper in here because I think all we got in solution is copper. All right, well, that just didn't work. Okay, well, here's an interesting development right at the very end. I dumped the liquid from here into here, and this turned cloudy. So obviously we do have a little bit of silver in here. It wasn't enough in like the 6 milliliters I pulled out of here and put in there to show up really. But there is enough silver in here to at least make this cloudy. But it doesn't look like there is a whole lot of silver in it. I would say just a tiny fraction of a gram probably by the looks of it. So not much silver at all there. So yeah, the silver, the bulk of it is still in here somewhere, somehow. Okay, well, since most of the silver is obviously still in here somewhere, I have decided to do a second test. This time, the bubbling wasn't really even done, and I dumped it into the funnel to filter it. Because I'm figuring if I leave this stuff in here for any length of time, the silver would just plate right back out or cement back out on the copper. So, quickly, I dumped it in. So we'll see if there is more silver in this stuff. Although I got to tell you, this does not look like bare copper. This just looks like dull silver plating to me. This does not look like we've achieved bare copper. So, I don't know. Well, we'll let this filter through and see what we got. Okay, this is taking an inordinately long time filtered through. I guess I must have smashed the cotton in extra tight. So we'll just test it right now without waiting. And the results ain't looking good. Nope. I'm sure there's a little bit of silver there just like last time, but certainly not any serious amount. You know, I was talking about getting 4 grams out of this much wire. I'd say altogether we've got a tiny fraction of a gram, just enough to slightly, ever so slightly make the liquid cloudy. So I guess I'm just not able to replicate 3,9-Deucin's process, at least not with this wire. I mean, he was using contacts that were silver plated, but they had a nickel underplating under the silver. So, you know, the nickel might have been passivated by the sulfuric acid enough for this to work, but I don't think silver on copper, doesn't seem to be working. Okay. So I think I'm going to give up on this. In the next video, we'll try something different. And by then, maybe we will have some of the material back from Toolman Tim that he processed through his flour sifter. If not, well, I can sift out some more. So we've got enough for a decent-sized experiment. And no hints, no hints. You'll have to tune in to see what I'm going to try next. And so subscribe to see that video and all the others I've got coming out. I've got a really interesting series coming out that I think you folks will be interested in too. So yeah, subscribe to see those videos. Check out my 2 other channels, Electric Geek 64, where there's electronics and retro computing stuff going on, and Mike's Lapidary and Fossils, where all my rock hounding, rock polishing, rock cutting, fossil hunting stuff is. So check those out. Like, subscribe, comment there. I'd appreciate it. And like I said, leave a comment. Let me know what you think went wrong with this process, because it did not work. And I'll see you in the next video. Thanks a lot for watching this one. Bye.